Our goal today is to take a heavy asynchronous motor from a dead stop to a high-speed blur, smoothly and safely. To make that happen, we need to bridge the gap between the motor's physical capabilities and the ATV320 drive. We do this using the drive's internal software, specifically the Simply Start menu, or SIM. Before we touch that software, the physical setup has to be complete. The drive must be securely mounted, properly wired to both the supply mains and the motor, and crucially, grounded. Skipping these physical checks creates a severe safety hazard. Applying mains voltage to an improperly grounded or wired system puts the equipment and the operator at immediate risk. With the hardware secured and safety checks cleared, we move from the physical wiring phase to the initial power-up of the drive. This graph shows how the drive handles its initial boot sequence. If your forward switch, digital input 1, or your reverse switch, digital input 2, is engaged before you apply power, the drive's safety logic will automatically lock out the system to prevent an unintended start. Ensure those digital inputs are toggled off. When you apply power, a successful boot-up is confirmed when the drive's digital display reads BFR. That is the first parameter inside our Simply Start menu. Reaching this screen proves your control inputs are deactivated, validating the system's baseline safety and clearing you to begin the configuration sequence. Every value we enter in this sequence comes directly from the motor's physical nameplate. Think of this plate as the definitive map for your drive's memory. This table shows our parameter inputs. The first entry is BFR, or standard motor frequency. You'll notice the factory default is set to 50 Hz. Next is NPR, the rated motor power. You enter the exact kilowatt rating stamped on your motor here. Then we step down to SNS, the rated motor voltage. This value needs to match the nominal voltage of your specific motor. Moving down, we find NCR, or rated motor current. Setting this correctly tells the drive the maximum electrical current the motor's internal wiring can safely handle. We follow that with two speed parameters, FRS for the rated motor frequency, and NSP for the rated motor speed, which is entered in RPMs. Finally, we set ITH, the motor thermal monitoring current. This establishes an electronic thermal overload limit, acting as a virtual circuit breaker if the motor begins to overheat. By exactly translating the physical nameplate data into the drive's memory, you establish the strict electrical boundaries that protect the motor from destroying itself. With the electrical protection locked in, we now configure the mechanical behavior of the motor to protect the physical equipment it drives. This graph plots our speed over time. We control the rate of change using ACC for acceleration and DEC for deceleration. Both have factory defaults of 3.0 seconds, dictating how fast the motor ramps up to speed and how long it takes to spool down. Those ramp curves operate strictly within set limits. LSP creates a hard floor for your low-speed frequency, currently at 0. HSP sets a hard ceiling for high speed, capping out at 50 Hz. Defining these kinetic limits guarantees that the motor won't jerk abruptly or spin faster than the attached machinery can physically handle. We are now ready to start the motor. Using a standard 2-wire control setup, engaging your digital input 1 switch will command forward rotation, while digital input 2 handles reverse. Once running, you control the exact RPM using a potentiometer wired to analog input 1. As you turn the dial, the drive dynamically scales the output frequency, locking it securely between the low and high speed limits we just programmed. If you engage the switch and the motor remains stationary, trace your steps backward. Verify that your control inputs were fully deactivated before power was applied, and double-check every value against the physical nameplate. If you need to open the panel to check the physical wiring, you must disconnect all power and wait a full 15 minutes. The DC bus capacitors retain a lethal charge even after the main switch is thrown. The Simply Start menu is ultimately a tool for translation. By feeding it accurate physical data, you give the drive exactly what it needs to produce safe, predictable, and reliable mechanical motion.